In Chapter 2, page 41 and 42, problems 35 to 38, deal with doing mathematical operations considering sig figs. When you're adding or subtracting, pay attention to place value. You are limited by the least precise place value. So, if I have 1 centimeter and I want to add 1.005 centimeters, what do I get? My answer is 2.005 centimeters, but now I need to round it to how many sig figs? The least precise place value is the 1, so I can only write down 2 centimeters as my final answer. If you can eyeball it and see you know it's going to be 2 centimeters, you may just write down 2 centimeters. But it's generally a good rule to like write down the answer and then round it afterward. Dylan. Dylan's question, if it's 1 centimeter plus 1.5, can we say 151 centimeters? I have 2.51 centimeters, but I have to round it to the 1th place. This is a great question. Thank you, Dylan, for asking this question. If you have a 5 followed by some number besides 0, round it up. This is slightly greater than 5, isn't it? It's 5.1. So we are going to round this up to 3 centimeters. And that will be your final answer. If it were 5.0, you are right in the middle. And here's what I want you to do. Half the time, I want you to round it up. Half the time, I want you to keep it the same. So how do you split your data? If I have 100 numbers, 2.5, 3.5, 4.5, 5.5, and half the time I want to round them up and half the time I want to keep them the same, what you do is, for the odd numbers, round them up. Even, keep them the same. That's the rule. I mean, that just splits your data in half, and that way you're not skewing your data so that it looks like it's a little heavier. So if I had 2.50, and I had to round it, I would round it to 2 centimeters. Because it is no bigger than 5. Can you see that, Dylan? It's 2.50. It's exactly halfway. So then I look at the number and say, is it even? I keep it the same, even Steven. But if it's odd, like if it were 1.50, I would round it up to 2. Because it's an odd number followed by a 50. Rarely do you guys ever have to deal with this headache. Right? I mean, how often do you have a number that's 50? Sometimes, but not that often. Okay? Any other questions about that? The 50s. Even, Steven, keep it the same. If you have to round to that number right after where you're followed by a 5, that 5's got nothing after it. It's odd, round it up. Even, keep it the same. 1.51 is going to round up to 2 because this is bigger than 0.5.
Oh, okay. I just thought you meant
Okay. Let's do 35B. Can we do 35B? I'm going to neaten that up because I'm going to be a perfectionist. 35B, can someone read me that one? 0.11?
Yep. So that's 153.1.
I guess I don't. They didn't have a decimal here, did they? After the 3. So that's 35B. And this is part of our homework, and you still have to do A, C, and D on your own, but I'll do this one with you. If you throw this in your calculator and you get 0.41 kilograms, $768.41. Someone want to double check that on a calculator? All right, thank you. But now we need to round it. When you're adding or subtracted, you're limited by the least precise place value. Which one of these is the least precise place value? Isn't that the most least precise place value? Of your measurements. These are the measurements that we took, right? So you look back at your measurements, Dylan, and you say, which one's the least precise? This one. So I'm limited to my ones place. So I have to round to the ones place. What is this if I round it to the ones place? 769 or 68? There's a 4, round the 8 up. Out of the side of his mouth, I get an 8, I think. 768 kilograms. That's your final answer. Questions? Let's do 36B. 36B, 5.236. I'm not getting dyslexic on that, am I? 236 minus pi, 3.14. Although that would keep going. Pi being a known number, like a given, it would be infinite. Like you would never let it limit your sig figs. Does that make sense? They didn't say pi, they said 3.14, which is close to pi. Yes. Yep. If ever I give you a number like that, and I say this is an accepted, like this is a known constant of the universe, it's infinite sig figs. And I will, in Chapter 5, give you some numbers like that. All right, but you guys won't have to worry about Chapter 5 and Intro to Chem. That's Chem A. 5.236, 3.14, I need to subtract, so I get 6,902. Is that right? Olivia? 2.096? Awesome. Centimeters, right? Ooh, don't forget your units. Never forget your units because it's science class. What do I round this to? Levi, what do I round this to? Yeah. Just that? Or 2 sig figs? What do you say? No, I can have more than that. This measurement here went to the hundredths place. So I can bring this measurement to the hundredths place. So what would that be? 0 is a tenth. 9 is a hundredth, but can't the 9 be rounded up? So it's 2.1, and go ahead and write that 0. Because now your answer shows 2.10. You should be writing this down. 2.10. This 9 forced me, if this had been 2.19, I would have ended up with 2.20. The 9 forced me to push the other one up. Because the 9 gets rounded up by the 6. If you round a 9 up, it becomes 10, which bumps you into the next place value, right? So there's our final answer for 36B. Now, that was 36B, final answer. Oh, don't forget your units, Jesse. We're just doing B of all of these. For homework, you need to do A, B, C, and D. If there's a D, do the D. ACD, right, because we're doing B. ACDC? I mean, yeah, just ACD. Yeah. Same way you do it anything else? No. If you have scientific notation like 3.1 times 10 to the second plus 3.1 times 10 to the second, and you want to add those together, you're going to get 6.2, and you don't have to round anything. You want me to make it a little bit cooler? Here, let's make it 3 times 10 to the second. Now it's more of a problem, because now you'd need to round it to the least precise, which is one place. So you'd say 6 times 10 to the second. Just make sure your scientific notation is lined up. You know, the same power. They have to be the same power to add or subtract. We did 36. Now we need to do 37B and 38B, right? Now, for 37B and 38B, you're multiplying and dividing. It's even easier multiplying and dividing because you are limited by the least precise number of sig figs. How many do you have? Who has the fewest? That's what limits you. So we're going to write that up here at the top. Limited by the measurement with the fewest. Sig figs. So, 37B, 120 meters times 0.10 meters. I'm going to end up with my units being what? Hunter, meters times meters. How about 12? 12.0 meters squared. And then how many sig figs can I have? Which one of these is the least number of sig figs? Olivia, Duncan. Which one has the least number of sig figs? Top or bottom? This guy has 2, this guy has. So you're limited to 1 sig fig. So you have to round 12 to 1 sig fig, and this is going to feel ucky to you because you guys hate to give up information, to give up the fact that you had a 2 there. But that's all you can write for this is 10. You have to round it down to 10 meters squared. If it was 15 with nothing after it, I would round it up to 20. Yep. 38B. What do we have for 38B? .2 meters. Is it meters? Is it 0.1? 60.2 and 20.1? Well, that's easy. Oh, that's fine. That means I can't do anything with these units other than leave them as meters per second. And maybe realize that that's speed. How fast are you going? Meters per second. So it's a derived unit. Meters per second. Is it really this easy? Okay. This is going to be what? 30? 30-something. Anybody do this on their calculator yet? Am I wrong? Olivia?
Yeah, whatever, friend.
Okay, so this is not right. Oh, you got scientific notation? No. 2.995. I like your answer better. I don't like this answer I had earlier. Let's pretend I never wrote it. Meters per second, 2.995. 0. Okay, what am I going to round it to? How many? I have 3 sig figs up here. How many do I have down here? 3. So this answer has to be rounded to 3 sig figs. Ugh. Boy, I thought it was easy. I guess it's not. So I have to round to this spot right here. And the 50 is going to round the odd number up, which is going to round this up, which is going to then be 3.00 meters per second. That's an S. It's kind of a messy S, but it's an S. And that's how you do these problems. I'm sure we'll practice this more before all is said and done.